projects and getting stuff ready for a crowdfunding campaign that I would like to tell you everything about in a minute. I am here. It's nice to have you all here again. So today's stream will be mainly, the main topic will be how to make panels in KiCad. So this is not my design, but actually from some awesome engineers at Apple. I got it from Scotty from Strange Parts at SuperCon last year, which he gave to me so that I can show it off at some point in my stream. And this is the time. So as you see, this board contains 4 assemblies for the iPhone. So you have 1, 2, 3, and 4. And these are so-called panels. You do that so that you can put it in a pick-and-place machine and you can assemble more than one board at a time, and you don't need a jig. This is also an interesting board because it's very thin. I'm really curious how they are handling those in their pick-and-place machines, but this is much more sophisticated hardware than I have. I had experience with a thin board not so long ago. I was assembling a tiny board for Joe Fitz. Where do I have this guy? There we go. Yeah, we were assembling these guys. This is a panel of I think 100 tiny micro badges. This is basically does it focus? Come on, you can focus on this. It's insisting to focus on my face, as per usual. Oh, there we go. So this is an Atmega with a connector, LEDs, and a USB connector on the other side. And this is something we were assembling because, as you might know, there's the so-called shitty add-ons. Those have, they have an I2C interface and some power. And you can plug them in and have some nice blinky stuff or some expanders and interesting things plugged into your badge. And this is a micro badge that can drive those. I still kept one of those boards. The problem we had with this in my pick-and-place machine, I didn't know that Joe ordered them in 0.6 millimeter thickness or 0.8. Doesn't really matter. It's thinner than the 1.6 millimeter thickness that you usually have for panels. It has very interesting physics because it bends pretty well in one direction, but not so much in the other. It's much stiffer. It's because of the slots. It's very cool stuff. But this was quite a lot of trouble for us because my pick-and-place machine, where the conveyor belts are, this thing was like slipping between the conveyor belt and the side because my machine is holding the boards when they come in by squeezing it sideways with its rails. And so I had to create a frame and glue some Kapton around the edge of this panel to make it rigid enough so that my pick-and-place machine was able to handle it. So that was interesting, let's say. We learned a lesson, and for next time I need some kind of a jig for this kind of thin stuff. But usually my boards and my panels are thicker. So this is Blackmagic probes. There is 10 boards per panel, and they are connecting with tabs. So the connection is called tab and route. If you order PCBs, you have usually the manufacturer is asking if you are doing V-score, which would be a small V-bit cutting a groove into the PCB so that you can snap it apart easier. It will leave quite a rough finish on the edge if you do it by hand and you just snap it apart. But there are tools for that. special blades that you can run through the grooves and get a better finish. Still, I usually prefer doing a tab and route because then you only have this one point or these points where it connects that are rough, and everything else is nice and smooth. So this is easier to remove. It's a trade-off. It's not perfect, but it's usually good enough. And I prefer the tab and route system. This is the same system that Oshpark actually is using. When you order boards from them, then you get those boards and they are broken out of a huge panel, and this is the full-size manufacturing panel of the PCB manufacturer, and they break it out, and all your boards are also attached in that panel using tabs, so tab and route. And the design that I'm using is inspired, it's very, very close to what Oshpark has listed on their page, and this is what they're using for their panels. Fun fact, they are actually not doing it themselves, it's actually the PCB manufacturer, but this is details. Anyways, I wanted to also tell you why I was gone for such a long time. So thank you all Patreons that are still supporting the channel, and I'm sorry I wasn't here to provide you with streams, but I was working hard and your donations are helping a lot to move this forward. So I was working on the iCEBreaker. This is this guy. This is a small FPGA. It's a 5k LUT FPGA on this, the so-called iCE40UP5k, and a FTDI USB to serial adapter that is used to program the FPGA, as well as serve as a USB to serial converter for the applications that you can run on this. So this guy is meant for beginners, students, for workshops. It's basically I met with Clifford and Edmund from Symbiotic EDA last December in Germany at CCC, and we talked about the fact that for the iCE40s you can get affordable FPGA boards, but they are not perfectly suited for workshops where you want to teach people, and they are not out of the box or have like myriad of issues. Like for example, the iStick has only 1k LUTs on their FPGA, which won't fit a RISC-V softcore on there. At least for now. Maybe there will be, there's another thing that is going on that I will get to in a second. But at the moment, that's pretty much the reality. So they wanted something that can fit in a RISC-V on there. They wanted something that has some LEDs on it and can be used also for projects. So this guy has PMOD connectors, actually 3 of them. One of them has a default board on there, which is also connected. So these bridges have wires in there. So they connect this PMOD by default to the PCB. So you don't need to solder the connectors. You can just use it out of the box. And then there's also this connector that has a special feature that this FPGA has, namely the 3 LED outputs. So this is high current drive pins on here. And this is a breakout for the flash chip. Anyway, so this is a thing Clifford came up with the specifications of what would be ideal for what he thinks for teaching people would be nice. I started working on that. I went to Vienna, spent a few days at his place, and designed this prototype. And now we are getting close to having a crowdfunding campaign. This crowdfunding campaign can be found at, if you look at the bottom of this video, there's a link. It's on Bitly, you can get a link to that. It's on CrowdSupply. There's a page where you can put your email in, and you will be informed as soon as this campaign starts. So we will have a campaign for it. It hopefully will be very well priced. We are working very hard to get good prices for the chips. so that we can get this nice and affordable. So moving on, first of all, hi Hedge, nice to see you. Welcome to the stream. Let's see if anyone else is in other chats. Yeah, there you go. Yeah, so we have only a few people. I know it is very, very late for most people here in the US, at least on the other coast. It's very late here on this coast. It's evening and it's Friday, but this is how it worked out for me today. Maybe some people in Europe will be waking up and can join the channel. Let's see. How much, so there is a question in the chat, how much of a limitation for basic self-teaching hobby project is the lack of DSP slices on the 8K, speaking of limitation of current boards? I don't know, I have not used the DSP slices myself. It is nice to have those DSP slices on the iCE40UP chips. So this one that is on the iCEBreaker actually has DSP slices. It's necessary for very specific applications, signal processing, obviously, but I have not used them myself yet. I know of several people that really enjoy having them. For teaching, it really depends on what we are teaching. In case of symbiotic EDA, they are teaching about formal verification. So they want to be able to demonstrate their bit streams and formal verification and show that a big enough design can be formally verified, and that this misconception of, oh, formal verification is only useful for very small things is not actually true. So that's the point why we need more LUTs, and this is why they need it for their classes, because they want to put a fully formally verified RISC-V core on that thing and show that it works. So this is the motivation there. And depending on what your project is, it's like if you have SDR applications, for example, then having the DSP course is great. But this chip is not the fastest, so it might not be fast enough overall for you. So you might need an ECP5, for example. That's something that Luc Valente is working on, so a tiny FPGA. He is coming up with a new board very soon that will have a much larger chip. It will be definitely a bit more expensive than this board and not as suited for teaching and classes, but it will be great for more complex applications and high-speed I/O connectivity. So it has differential pairs and it has SerDes capabilities. So it really depends on what you want to learn about, where do you want to go, which board is the useful one. Yeah, the EX specifically, yeah. Yeah, so this board is supported by NextPNR already. So it is mostly for those that want to get into FPGA development, want to learn the basics and build something, develop the skills of writing Verilog or using MyGen or using Chisel. Or making FUPI, something that Mithra is working on, that will allow you all Python system that is generating code and HDL and code for your soft core. It's like it's a full framework. It's very interesting. Yes, definitely. Small FPGA are still useful for small projects. So let me get to what. So I'm building this iCEBreaker, and basically the more I just create that platform and look at the PMODs that are available or not available, I just run into an explosion of different projects that I want to build. I don't have the time to build them all, but it's just incredible how much you can do with just 5K LUTs and the 100 megahertz that this thing can run at. So I was building also while, like in this few last months while I was not streaming, I was building a ton of PMODs. Some are based on other people's design, like for example, Black Mesa Labs. He created a bunch of PMODs for HDMI. So I made his my own version of his 1 bit per color HDMI board. So this is this guy, and a 3 bit per color HDMI board. This will allow for doing retro computing, connecting it to your monitor, and being able to display stuff and write games and renders and pixel shaders, stuff like all this stuff. This tiny chip can do that. It's like this is all totally possible with that chip. You don't need a much bigger thing. There is also HyperRAM. Yes, that is true. There's I have it somewhere here. This is the HyperRAM board. That's another PMOD. Yeah, so that's HyperRAM. The nice thing about this thing, it behaves like a synchronous RAM module. So you don't need to run through refresh cycles, which you need to do with dynamic RAMs. So it is faster, has more density, and behaves like a simple SRAM chip. This is and also doesn't require as many pins as other solutions. So HyperRAM is fast, has a lot of memory, more modern, but still easy to interface to compared to older things. So this one is 3.3 volt version, and it can run up to 100 megahertz. And it is DDR, so it is 200 megabit, I think. Something like that. I think it has more pins. Oh yeah, it has 4 bits or 8 bits. That's what I don't remember. Yeah, it's 8-bit wide. It's 8-bit wide bus, 100 megahertz DDR, so it's quite fast. Yeah. Yeah, it definitely can saturate the iCEBreaker, so that's good. Other SRAMs are slower than this, so yeah. Yeah. What else? Lots of questions. That's nice. Nice to see you all here. Welcome, Bob. Nice to have you here, and nice to have Cool Lantern here too, and to ask all those questions. That's very exciting. Okay, so PMODs. What next? I also made something. So I was excited about. You probably seen that on the internet float around. This really awesome cubes. With LED panels. So this is an LED panel. I should get the version that doesn't have paper diffuser on it. So I think this is I have the 32 by 32, and this guy is 64 by 64. So it's double the resolution of LEDs. Let's see if I can find the full module. There we go. So this is this thing. This is amazing. Blinky, I love Blinky stuff. So this guy and this guy, oh my goodness. So this is more standard. This is something I got from Adafruit, and this is a P4, so 4mm pitch, 32 by 32 RGB LED panel. And this one is a 64 by 64. So they have already all the drivers on the back. This is how you make TV walls, like video walls on either indoors for so the 32 by 32, I don't know, you have to look on Adafruit how much it costs. They are very, very cheap if you get them from AliExpress. These are about $20 from AliExpress, also not very expensive. So you get 64 by 64 pixels for $20 each. Plus shipping, obviously, but yeah. I really wanted to play with them, so we need a PMOD for that, right? They run on 5 volts. You can run them on 3.3 volts, but then they shift into the red spectrum because the LEDs are not driven correctly. If you want to run them so that you get good, clear colors as calibrated, you need to run them at 5 volts, and you need I/O that runs on 5 volts. Woo. So now, where is this guy? Somewhere that I can't find at the moment, I have made a PMOD for that. Yeah, I should have been prepared. There we go. So this is a PMOD that can connect this LED panel. So there you go. Idea after idea after idea. It's like we need also radio PMODs, we need like switches PMODs, and so on and so forth. So anyways, tons of PMODs. I was working on that. I was very busy with it. And I was writing a lot of examples in Verilog. I was writing some examples from APIO, which is based on the platform IO tool framework that is developed by the guys from FPGA Wars. They are making this really wonderful UI that you can create logic by just dragging lines together and creating schematics. It's really good for teaching about how logic works, so that you don't have to, so you can do it just intuitively with schematics, and it's called iStudio. So this is a really great system. They are working on that. I was adding support for this for the iCEBreaker. Yeah, and then as I was telling you regarding SuperCon, that I actually wanted to segue away from, but I failed at. I submitted a workshop for FPGA for SuperCon. SuperCon is happening next month, the 1st to 4th November. And my workshop was accepted. So now I needed some addition, and so I wanted to base it on a wonderful workshop developed originally by Joe Fitz. And he created this WTFPGA workshop to teach you about basics of Verilog and how to write that and how to create also simulation. So we will be using I will be converting his workshop that was made with I think the Xilinx iCE or whatever it is called, the toolchain of theirs, and their proprietary tools. So we will be converting it all to open source tools using iStorm, using NextPNR, using Yosys, using iVerilog for simulation. So that's the plan. But his workshop also requires some iCE. Thank you, iSE. And I will be converting that. Of course, it will be after the workshop all published, so you can follow that workshop at home. That's not a problem. Yeah, well, Quartus is not much better. Anyways, so so all the open tools, and yeah, so we need also PMODs for that because his workshop requires an 8-segment display. So what I got, I don't have them ready. I ordered the PCBs, but I have this beautiful, sorry for the loud noises with the tubes, but I got some 8-segment displays today, which I'm very excited about. Yeah, 8-segment displays. So we will be making PMODs for this. And there will be another PMOD with 8 dip switches. So this is what the workshop needs so that we can do it the right way. And this is why the iCEBreaker has those PMODs, so you can adapt it to your workshop as you need. Yeah, Vivado is definitely an improvement, but yeah, especially, so how I feel about all these proprietary tools, they are in certain sense, professional tools, but they are also overloaded with features. So especially if you are getting used to and learning about FPGA, you don't want all this clutter around it. But yeah, anyways, I really enjoy using the open tools that don't take like 30 gigabytes of your hard disk away. All right, so I was making those P-mods, as you might have seen. I'm posting everything on Twitter, so I'm posting every day what I'm working on, so please follow me there, and you will see what I was working on. All right, so let me catch up on the chat a little bit. Yes, so Hedge is pointing out that graphic-based circuit design doesn't scale well. That is correct. But I don't think this tool is meant for that. It is meant as a teaching tool to basically make you start thinking about what you're building with the digital design. More like, oh, instead of having a breadboard where I create wires and use like logic chips to create something and learn about it, I can do it on the desktop and then put it on an FPGA. I think that is useful. As a teaching tool to make it easier for you to learn about logic design. And then eventually you will have to transition to writing actual HDL, obviously, because for the more complex stuff, you will have to do that. I don't think it is meant to be the be-all solution for creating HDL. I don't think this is their approach there. What next? Yeah, the proprietary tools we all hate. I agree. And yeah, Cool Lantern agrees with me. That's nice. Yeah, it was so far, I really like that experience. It just pops. It's like you do it, you use it, and it's just happening. Things are happening. And if you start up Vivado, that is arguably the best proprietary solution at the moment. You press the button and you can get a coffee. It will always, like the simplest design will take several minutes to synthesize. And the open tools, it's like this. It's really wonderful. You might not get as perfect design or the perfect optimization at the moment, but I'm sure that over time it will transition and everyone will be like, oh, well, just like you are using GCC a lot for production and serious stuff, you will be using these tools or their successors for serious stuff in the future too. I already use it for production. It's like I do some consulting stuff and I use the open tools to design their stuff. And it works and it creates useful designs and it's stable. So there you go. Okay. That said, unless there are additional questions, let me get a sip here. There we go. Lots of talking requires some water. We want to look at creating a panel using KiCad, the version 5. I was saying in the past that that it would be nice if KiCad had better tools for it, but on the other hand, it is still possible. And several people were asking me, so how do I do this? How do I copy it? And it's quite an elaborate, like you have to like wrap your head around it a little bit, because you cannot just cut and paste stuff together to make it happen. You have to use the correct path to create your panel. So this is what we will be doing now. I decided to do it today because I need to make panels so that we can make enough boards for the SuperCon workshop. So this is what we are doing here today. So let me see. I hope I'm not creating some weird noises with my receiver. I'm trying to find a good position here. All right. So let's see. So this is, let's switch over to the desktop view. There we go. And so this is the iCEBreaker. This is the revision version 1.0b. I will be making one more adjustment between now and when I send it out to the fab, because I want to add 1.8 volt supply for the GPIO banks, but that's a detail and not really relevant to the stream today. So if you look, I was also asked to talk a little bit about how my structure of my projects is. So I will do that really quick. If you, let's see, do I have tree? I don't have tree. Anyways, so my projects are usually, this is the top level directory, and I have, so if you look in my iCEBreaker hardware or iCEBreaker Git on GitHub, you will see that I have just one hardware directory and one lib directory. And in the lib directory, I have pretty KiCad libs. These are my personal library of parts that I share between all my projects. So lib pkl, and you can create more additional subdirectories. So this is how I manage my parts. I have the symbols and parts and 3D models. So this is where this package 3D subdirectory there is. These are 3D models. Let's see, my phone is going crazy. And I have this one GitHub repository that contains all my footprints, all my symbols, all my 3D models that I share between my projects. So next, I added to my project Git repository as a submodule. So Git there's just the PKL, and this is linked into my project. I hope you can read this well, because yeah, the terminal seems to be visible. Good. So now that linked in, I have the hardware directory. So you could have also a firmware directory in here or other things for your project, but hardware directory. And here I have multiple versions of stuff. If there could be also one more layer here if it was, for example, my PMOD project has one more layer in here. So it is hardware, PMOD name, and a version number, and then the version number of the hardware. So we go into version 1.0b, and this is the actual KiCad project. And there are two important files for the library management in here. Version 5.0 of KiCad got these new files. One is called fplibtable, and the other one is called simlibtable. So fplibtable is the footprints, and it links the footprints within the project. And the difficult part about this is, if you use the UI to add the paths, it will create absolute paths in here, which is very annoying. So what I do is add the libraries in here, and then edit it by hand so that the path is relative to Kai project mod. This variable here, this one, is substituted by KiCad itself to point to the KiCad project directory. So this is the directory we are in at the moment here. And thus, I need to go 2 layers up, // and then libpkl, and then the library that I need. So there's multiple libraries that I have in there. I have all of them added usually. So I copy these files from design to design to design, and they are local, so that if another person opens this project on their computer, they don't have to worry about me having to install the footprint and symbol libraries separately that are not part of the project. So all you need to do is do git submodule init, git submodule update, and have that whole library in that Git repository. The same thing applies to simlibtable, And this has the same problem with the relative, like absolute versus relative paths, but you can do it by hand and create this. And you can copy it from project to project. So this is how I manage my projects. If the hardware project itself is requiring a specific 3D model or a specific footprint that I don't want to add to my global library of parts and footprints, I can always create a subdirectory in lib to just drop it in, or drop the file into the folder itself with the library and the footprint, and then link it in here, also relative to the project directory. So that's how I do it. I hope that clarifies how I manage my libraries, especially in version 5.0, because this changed from 4 to 5. If you have questions, more questions, I can go into more depth during the next stream or something. So we will see. All right. So next, let's try to get to the actual thing that we wanted to talk about is and create a panel. What I like to do is create a subdirectory called panel, then copy the iCEBreaker KiCad PCB. So this is the KiCad design file into panel, and then call it so iCEBreaker KiCad panel, and call it panel. So this is the first step. Second step, I will copy a template that I already have for another design, because we are doing it from scratch, but I already made the frame that I wanted to use, and you will see it in a minute. So I will copy from a different project that I did yesterday, iCEBreaker pmod, let's see, 7-segment. Oh no, I can't use it because I need the 4-layer version of it. So let's copy it from Blackmagic BMPM to hardware, and then we have BMPM2 version 1.2.1D, let's say. No. C panel, there we go, and then BMPM2 panel. All right, so let's copy it over here. And now, this is the important part. You don't open KiCad all the way up, like you don't use this manager. So you don't start KiCad with KiCad. To create panels, you start PCB new on its own, standalone. That's very important. You will not be able to do this if you open the project itself. So I open the iCEBreaker panel like this. It will complain about the profile. That doesn't matter. And now I can, for example, delete these. We don't need those. The helper lines. And do we want to create an origin somewhere? No. Let's import. So now in File, you do append board. And we will have to find project, iCEBreaker hardware. I wish KiCad was automatically going in that directory, but okay. Panel, there we go. And get the Blackmagic probe ride-rec panel. Yes, please. Let me move this. This is very, very heavy because it has all those Blackmagic probes in there. That is okay, because we will delete them in a second. So I'm putting it here to the side. And let's remove the Blackmagic probes from here. So we will adjust that frame Ooh, what is it doing? It's jumping. Escape. Will it react? Yeah, KiCad is a little bit overwhelmed. Let's see if it will crash or something. I overwhelmed KiCad. Okay, wait. Let's do it again. Append board. Oh, why are you not remembering the path? Yeah, poor little KiCad, yeah. And stop. Okay. Drop. Breathe. Okay, all right. Now let's remove those black magic probes from here. And do this. No. Okay. Yeah, because it's still selected, that's the problem. So unselect everything. There we go. Now. Delete. Yes, please. Okay, so we did that. Let's clean up more. So we can disable this rat's nest because we will not use it and we will ignore it anyways. There we go. So this is a cleanup you have to do only once. I could have used a different design that like for this if I was doing it on my own time and not dragging you people along, and then it would then I would probably use some other design that I could come up with that has 4 layers. So why am I needing that? It's like other designs don't have this swatch here and are for only 2-layer design. So they miss this inner layer markers. I like having them for manufacturing monitoring. So I created this frame a while ago. So for example, this has to be, this is a change between an older KiCad and newer KiCad. So these are not plated holes. So we have 3 holes in the corners. Each one of them is for mating pins. I usually don't use them, but it is nice to have them just in case if you need to put them in a jig. And then we have on both sides these fiducials, and we only need 3 of them. That's very important because you want them to be have enough of them to have a good information about orientation and if there is any skew in the panel. And you want them so that if you rotate it in any orientation, you will not be able to have them in the same position. So basically prevent you from putting the panel the wrong way around into the pick and place machine. So you want the machine to throw an error if you put it the wrong way around. So you want the fiducials to be somewhat asymmetric, rotationally asymmetric, as well as if you flip the panel around. So the backside is also incompatible with the front side. So if you put the panel upside down into the pick and place machine, you still will not be able to have the fiducial in the same position, and the machine will throw an error that you put the panel wrong in. So this is an important lesson I learned fairly recently, because PCB manufacturers are never telling you these details. Oh, hi, John. Nice having you here from Canada. Welcome to the stream. And welcome, Julian. Nice to have you here too. Let's see if there are other people in other chats. That's good. All right, so everything is working. All right, so I also have in the frame, I have this legend. This is manufacturing information, fab notes. It is sometimes useful. I usually don't, it's more of a reminder for myself when I put it into, when I place an order for the PCBs, I can refer to this list and make sure I set everything in the online order. There we go. All right, so what's next? Next thing is we need to align. So as you see, I have these footprints here that I created a while ago. And these footprints are representing the tabs. I have 4 drills. I have 3 drills on each side. They are the so-called mouse bites that will snap off. And it has the dimension of the width. This thing is 3 millimeters in height, so 3 millimeters like this, and also 2.5 millimeters or 2.4 millimeters wide. This is based on the roughly how they were described on the OSHPark website in their wiki. But they had it in imperial. I converted it to metric because I prefer designing my boards in metric because it's the future. Haha. All right. What next? Next, we need to align this thing. So we can, let's leave those. But we could just do this and split it apart into 2 sections. Maybe even, let's think. If I do this, then I can leave this, let's see. Yeah, no, actually I want to move this section away. Like this, to split it apart and go into just 1 millimeter grid maybe. No, let's stay here. Just move this away so that we can get just the left corner free, and do this to get the, just get the left upper corner. All right. Also, we have to discuss how I want to panelize this. So my idea was I will have 2 horizontally and 3 vertically. This will fit my pick and place machine. It won't be too large, but still I will get more than just one iCEBreaker into the pick and place machine. So that's the goal here. We will now take this corner of the frame and then move it so that we have exactly 3 millimeters from the edge, this panel aligned. So now, this is 0.5, yes. Let's see. We could create, let's do this. So we can, I'm not sure you can see this in the recording, but yeah, so this is obscured by my video, but here in the right lower corner, if I press space, I can get relative coordinates from the cursor. Maybe I should move my video away from here. Let's do this. Let's move this guy up to here and this here. I hope this will not obscure something else that we will need in a minute. So here, if you look in the right lower corner, there are relative coordinates. And these relative coordinates, oh yeah, so actually this is visible. Maybe I can just move it Yeah, I will now be obscuring all these tools on the right upper corner. It's not that necessary because we will mostly be just moving stuff around and adding cutouts. So it's not that necessary. We will leave it because the relative coordinates are more important, I think. So now, as you see, my relative coordinates are 0, 0 here in the corner. And I lost my marker. There we go. So let's choose this, and then with Shift I can select more here. And now if I go into the corner and use just keyboard to move around, not the mouse. This is the nice thing about KiCad. You can move the mouse around on the grid using just keyboard cursors. And I move them, and then I try to match -3 millimeters from each end. 3 and 3. 3. There we go. So now this corner is already aligned. Now I have to decide where I want those tabs. We don't want a tab under the USB connector. That's very important because this thing hangs over the edge. So we don't want a tab there. What we want is probably 2 tabs on this edge, and then just have these boards like 3 down in this direction. I'm not sure we really need to connect them horizontally, to be honest. The problem would be if I copy this over, there is not really much connection that I can do here that will not interfere with the USB connector. So we will do it similarly to the Blackmagic probe and just have those tabs connected only to the sides of the board. Usually it is a strong enough connection. So let me just remove this here. And let's just go from the edge, probably 5 millimeters. Let's go like this. Move. And then let's see. Let's go to the edge here. Let's do a 0 and then 5 millimeters. Let's do 2, 3, 4, 5. Is that good? Should we go more? Maybe we should go more. Maybe 6? 6 millimeters? Does that look good? Yeah, it's like further away maybe from the hole. Although we could have it also connected just right next to the hole. But then there's thinner material. I feel that this is better. So let's do this. Let's see. 5. Let's do 6 millimeters from the edge. That's 1. And this, we do the same thing. Reset again. So I'm using the space bar to reset the move exact. Control M. Control M. Uy, uy, uy. Yeah, I have not used Control M before. That is pretty nice. Can I use... Oh, but like, what did it do here? This is weird. Okay. It somehow failed there. Okay, let's move this thing here. Move. Okay, Control move. Move exact X and then 6. Let's see how that works. That is nice. I have not used that before. Thank you, Morgan. That is a good tip. I learned something today. Today I learned how to use move exact. That's nice. Yeah, I was always using the relative coordinates in the UI in the status bar so far. So that's what was going on. All right. For the frame, I don't really care that much at the moment. All I care is to create the tabs here. Yeah, we are learning here. And we don't need this tab. And what we need to do, that's the important part. The outline of this board does not have holes here. We need to add them. So this graphic outline, we will split it and move it so that it is, yeah, I'm on the other grid, so I want the 0.1 grid. Yeah, it's 0.5 millimeters off this the width of the tab, but that's okay. We can just do this. Oh, that's interesting that there's a double here. Let's not do that. All right. And now let's connect it to here, and this is where we will be. Yeah, we are all learning. My phone is vibrating a lot today. Awesome, awesome. Okay, so now let's do edge cuts. So I'm selecting, this is covered up, so I'm selecting edge cuts and using the draw tool, and I will add the missing trace, and or I mean the outline, and missing outline here. That's one. And now what we need to do is to know what our height is. And our height is 37 millimeters. And this means that our vertical offset is 40 millimeters. So now I will choose the two. Whoop, that's not what I meant to do. These two. And then right click, duplicate, create array, and do horizontal just 1, vertical count 2, horizontal spacing I don't remember yet, and vertical is 40 millimeters, create, so that I have here reference to make the cutouts. This will be easier than measuring. So I create the cutouts. And another. Whoop, with these and cut out, move, and there we go. Okay, so now I can remove these. Oh, this is an interesting thing that I have to mention. It's like, depending on which corner you start selecting, it will behave differently. If you select from left corner downwards, then anything that is within the bounds will be selected. So you see, I'm not selecting the tab. But if I go like this, then the tab is selected, and anything that is within the boundary. If I select from the right corner upwards, then the selection is blue, and anything that intersects that square is being selected. So now I selected the item. So that's an interesting tip too. All right. Now that we have this done, we can create an array of these boards because we will have to add the rest of the frame in a minute. So now I will select everything here, including the tabs, and wait, I have to measure. Let's see. So 73, so 76 millimeters offset to the right. So select, and now right click, create array, and do horizontal count is 2, vertical count is 3. 76 we said, I think, is the horizontal pitch, and vertical pitch is 40, and go. And bam, KiCad had to think for a second there. but there we go. Now we have already panelized this stuff. Now we need to just finish the frame and we are done. It's a little bit of fiddle, but we will do that in a minute. So first thing first is let's move this frame to its final position. So I want to know, there is an option to have the, so maybe I will go in preferences, display options, I think, and cursor, full window crosshair. This is the important part that I was using before. Always display crosshairs. Maybe that's what it is. Is it that? Oh yeah, so now they are always enabled, independent if I have a tool selected or not. That might make things easier here. So now let me get a reset here. And now I can select this and go to this corner and move. And let's go. So now we need to be 3 millimeters to the right, 2, 3, and 3 millimeters up. Perfect. Bam. So the right corner is done. And now left lower corner. Let's do that too. For that, we need to pick up the corner again. And space. And then, let's see, I think this is where it is. Move. Yeah, it's relative from the position where it is, so I don't think the move exact would be useful at the very moment, but there we go. Okay, so yeah, I don't like having this crosshairs all the time on. Let me disable that again. I'm not a fan of this, because it gives me this feeling of if I have a tool selected or not. Yeah, it's just a personal preference, I guess. There we go. We have that connected. We need to connect this. Done. And now we can actually remove these because we have to redraw them anyways. And let's see, where are we here? This is something I have to pick up somehow. What is my corner here? Because I can actually just do this. I have to drag the corner here. I think there is like Alt gives me coarse grid movement. Ugh. Yeah, this panel is larger than most of the stuff I ever do. I see it is not straight. Is it hitting? Yeah, this is how I should do it. I should have this picked up as on 0. And 0.1. There we go. Now it's fixed. And now I think Alt, Control. Yeah, there we go. Control is the coarse movement. So you can have Control and then scroll around to move coarse. Control and down. And then it goes by increments of 10, I think. All right, so one more thing we need to do is, because we are missing the tabs here on the bottom, we do the same thing as we did to create those gaps in the first place. Copy, create array, just horizontal count is 1, vertical count is 2. Bam, now we have the additional tabs. Now we can create the board outline. So that, after we are done with this, the next, and we finalize creating the outline, we can test this by going into the 3D rendering of the panel, because it will throw an error if the board outline is not contiguous. So if you have some error in your board outline, it will complain about this. This is a very useful thing. I'm sure there's some other source to get that information, but that's what I will use. Okay, so we got this. So bottom is done. Now we need to connect the top. Bam, bam, bam. Connect the top. And why we don't need it segmented. 1. So the cool thing about this system is that what I like to do after I'm done with this is to create a copy of that design file and save just the frame and the necessary parts to create the frame. So you don't need to redraw things another time when you change the design of the particular board. All you need to do is copy the board design file, import the frame template, then align it with the board, and then just create an array, and it fills in very quickly. So all you will need, so if you have this panel, what you would do is delete all the panels, leave the tabs on the bottom of the panel, remove everything and leave the tabs on the top. Then you align it with the top, mark just the first board and its tabs that are still in the design file. So you leave these two, remove this one, leave these 4. And then if you do this, create an array, blam, it's all copied, and you have already the 6 replaced with a new design of the board. So yeah, there are few details that I want to fix up. So first of all, let's check if my board outline is correct, and I will press Alt-3 to generate the 3D rendering, and let's see if we were successful or not. Bam, it worked. Yeah, that's the 3D rendering. What I'm missing here are the buttons, so I guess the link to the 3D model of the buttons is not correct. But yeah, this is the board. That's very exciting. It still says Blackmagic Pro, but we will change that in a minute, and we will move this around. Let me show you one more thing. It's like, if I had a mistake, like for example, I move this and I'm off by just one grid space here. Then I go into the 3D rendering. Let me wait for that to render. There you go. So first of all, it is filling everything in. There is no internal cutouts. And it says it is unable to find the next graphic element with the endpoint of coordinates 182.1 by 26 millimeters. You remember that 128.1, 26, 128.1, and then you go in the full. This is the full coordinates 128.1, 26, and you see, and you immediately find where the error was. Now you adjust it, the 3D rendering will work its magic, and it's gone again. So it works again. So it's a very easy way of fixing the outline and making sure it is correct. Okay, so now all we need to do is decide what the center is, and the center is here between these two. I want to get my get this thing, move. Let's see. And just center it between these two. And 1.5. Chunk. So that is centered. Now this fella, let's change the text. And this is iCEBreaker version 1.0b. Kapump. iCEBreaker version 1.0b. Okay, it's adjusted. Now we just need to let's select these two. Maybe just one, because then it will center move. And let's center it at the center of the USB connector here. 1 and 2. And 2. And now we want to move this. Let's do this. So the interesting thing is, how do you make the measurements? Because I have them in metric and in imperial. So you do that by selecting which type of a measurement system you are using. So I will move this 85 millimeter one and adjust its width, and it's staying in millimeters. That is fine. And now if I do this with the inches one, look what's happening. I move it and it switches over to millimeters. So what I have to do is go on the left, select inches, and then it will be inches. And when I let it go, I can switch back to millimeters and it will be fine. But for now, one more thing I have to do is adjust here, because there's not enough space for the text. There we go. That's one. Now let's go back to millimeters. Let's move this thing here to the corner and to the corner. Oop, what is going on here? Corner and to the corner. Now it is correct. And this goes to the corner. Now we can switch over to imperial. There we go. And all we need to do is also adjust so that it is a little bit better. There we go. So now that it is done, we can also look at our fab notes. So this is pretty much finished now. So we have the whole panel. And all I need to do is adjust my specifications if I need to. I'm sure there's something I will want to get adjusted, like maybe the silk screen color or whatever. And then I go into the Gerber Generation, and then I can generate the drill file, and do plot. This will generate the... So this is an important thing. It will complain that the zone fills are out of date. That is fine. You can regenerate the fills because you have all the net information. So the fills will not break if you renew it. but I usually leave them untouched and make sure that the file that I copied to create the panel had the zones updated. So I'm saying no here. And I can close it. Now we have the Gerber files. Gerber, gerbv. So I use gerbv, not the gerbview of KiCad. It's I feel it is a nicer tool. Also, using someone else's code base to read the Gerber files than the one used to generate it is like an additional layer of safety that I feel is useful. So yeah, there we go. So these are the Gerber files. We can look at them in detail, audit, and make sure that everything is correct. So this is the fab layer. Then we have the solder, so the paste. This is for the stencil. We can check that. Next one is the edge cuts. We can leave it. Next one is the drills. We can leave it on. Silk screen. Check if the silk screen. I like to flip them on and off too, because it's better to have the your brain to pick up if something is weird because it is moving. Then the solder stop, that looks fine too. Then we have the copper, that is fine too. Then we have the first inner layer, which is ground. Then we have another inner layer, which is power, and you see there are some traces for additional power supplies. Then we have another copper layer for the back, and then we have the mask, silkscreen, and paste, which we don't need because these are jumpers, but that's a separate story. And the fab layer for the back. There we go. So this is how you make a panel, and we made it in, I think, a pretty decent time. Then the next thing I will do is also create, so I can save this. So this is saved. I can file, save as, rename this as the iCEBreaker panel template. Save. And we will do what I described, namely, I will do this, let's see, like this. I can select, delete. Yes, I do want to delete this. There's still some holes left. Delete, yes. Then remove these two tabs, delete, and now I can save the template and reuse it if I update the other board. So now let's open the original panel. This will reload the panel, and yeah, that's pretty much it. So I hope this was useful to learn how to make panels. I will continue chipping away at things. I'm not sure when the next stream will be. I hope there will be something interesting to show, and I will find some time to do some streaming for you. Let me know if you have any additional questions about KiCad, something I can show you. Maybe that you would be interested in. I have a bunch of things that I have to work on still. For this iCEBreaker, there are two to-do items that I have to still do. Adjust the tact switch footprint, because I've got some really nice buttons from AliExpress that are nicer than the ones that I was using before. So let me switch to the camera view now. What was it? It's full face there. There we go. So I got these really pretty buttons. I'm not sure you will see it. Yeah, they are larger. I should have a microscope for this. Anyways, These are larger than the ones that I was using before. They are more affordable. That's very important for this project. But they have a slightly bigger footprint. They still fit. I can put prototypes together with the smaller footprint, but I definitely will need to adjust it for the final production so that it is matching, but it should not be too big of a deal. Then the other thing was, it was a request from Design by Twitter. So someone mentioned that it would be nice to allow for a jumper to connect the 1.8 volt output of the FTDI chip to the GPIO bank power supplies. I want to add that jumper. The problem with that is I am not sure what impact this will have on the FTDI signals coming to the FPGA. So I need to test a few things. I might do this on stream, but I might not. It depends on how fast I have to do these things. I really want the campaign to start very soon, like hopefully before the end of this month. So I still have a lot of work to do, including shooting a video, writing more description for the crowdfunding campaign. This is why I was working on some of the PMOD so hard, because I feel like it would be good to have some demos and some examples and some stuff to show. Besides, we already have a bunch of stuff. We have some Blinky stuff, we have PWM Fade stuff, we have the PicoSox, the RISC-V implementation of Clifford's running on it. So we have some demos, but I really would like to have the LED panel working, because this would be actually a compelling demo, and having a good video for a crowdfunding campaign, in my opinion, is very important. So having some moving animation type of stuff is a good eye catcher, and it is better for all of us if more people pay attention to the campaign, because then we can make it more economically. So for now, please check out the pre-registration page. Drop down your email address on the crowd supply page to be notified when the campaign goes live. I hope you enjoyed the streams. I have to say big thank you, and like especially for the patience to the Patreons that are making the streams possible. They are like really supporting this and allowing me to work on this kind of projects. So I would like to give a shout out to James Neal, to Jordi Paquet Rodriguez, Garrett Kelly, Bob Miller, Sid Price, Keen Measles, Eduardo Costa, and Kate Temkin. Thank you so much for all your support and your donations. These are all the people that are donating $5 or more on Patreon. That is helping a lot. Every penny counts, so thank you so much. All right, so follow me on Twitter, ask questions if you have any. For those that are seeing this stream later, welcome, and thank you for watching and taking your time. I know these streams are long, but this is currently the best I can do for editing them down into something smaller. I don't really have the time for that. So anyways, thank you so much, and see you soon. And if you have been, thank you for watching. Bye.